we know a little bit more. First of all, we're going to note that, well, we're going to recall or note that the height of min is normally distributed. What does that mean? Do you guys remember when we talked about that? What does it mean to be normally distributive? Anybody know? What does that mean? What does it have? Yes, thank you. Thank you. This is also code for what? The bow-shaped curve. Okay? Now remember, or here's how it works in this setting. If you construct a frequency table and you notice that your distribution starts to look how? Something like this. Looks like a bow. What's the story? It's normally distributed. And we actually know for the height of men, height of women, weight of men, weight of women, things that grow or happen naturally. There's a lot of different things. We're going to study this distribution in more detail in the future. But if it looks like a bow, what's happening here is the center is in the middle here. This is where the mean is. Okay? And so we have another fact that applies only to the normal distribution. It's the 68, 95, 99 point, I think it's 7. Yeah, 99.7. This is known as the empirical rule. Meaning that if you have a normal distribution, okay, like the height of min, 68% is within the first standard deviation of the mean. 95 is within the second standard deviation of the mean. And the 99.7 is within the third standard deviation of the mean. Okay? What that means is 68% of your data is within that first standard deviation. 95 is within the second, and 99.7 will be within the third. So what I did was I showed you z-scores based on heights of min. Okay, we could have used a lot of other examples. And then I said, oh, by the way, you know, we got Cheryshev's theorem that states, you know what, given any data set, whether it's uniform, skew, doesn't matter, or normal, you know, the definition of k of 1 minus 1 over k squared tells you that your data will lie within k standard deviations. It's at least this value, at least, meaning it could be higher. And if you look at this theorem and you go, ah, we just computed here 75% of the data is within the second standard deviation of the mean, well, this language is at least, so it could be more. We know for a normal distribution, it's 95. Okay? So here's what I'm going to say here. We said that this was 75%, but what I didn't mention that, you know what, the height of min is normal. So now that we know that it's normal, we can say that, you know what, 95% of min have a height that's below this value and above this value. Isn't that most min? 95%? Did you guys say? Slightly above 6 foot. You guys say it's 6'1". I'll have you do the computation. So does anybody know someone who's about 6'1"? You do? Who do you know who's 6'1"? Your friend. Well, what do you know about his height then? What do you know about his height then? What does this all mean to you? Next time you see him, what are you going to think? More than above average. He's definitely above average, but what else? He's what? Good. See? You guys are thinking that's the way it should be. Good. He's what? He's what? He's unusual in terms of his height. Yes. Unusual. Thank you. Thank you. Okay? This is what it all means here. But fine. Okay. So we're looking at measure of position. We're going to look at some of this stuff in much more detail, but I thought I'd talk about it and point it out. You know, it's important. In fact, here's what we're going to do. You guys notice that sheet I gave you? That sheet I gave you, there's a few things associated with that sheet. Okay? And if you notice that I have this titled test scores, is that true? You guys see that there? Test scores? And so, you guys looking at this sheet? See what I'm talking about? You got test scores there, right? What do you guys see there? What's the first test score? Well, no, the score. 118. Good. What's the second score? And the third is? The fourth? Now, I just happened just to note what the standard grade would be. What's that standard grade? We did that last time. Right? Remember that scale I gave you last time? So these are the test scores or the test results that they'd get associated with each score based on the standard scale. You guys okay with that? How do we grade your test? On the curve scale or the standard scale? Good. And then I went further. You guys see the Z? I computed Z values for like the first 10 scores. How did I compute those Z values? What did I need to have? The mean. Do you see a mean down there? What's the mean test score? 108.4. What's the standard deviation? So what I did is I used that Z-score formula. Z is an X value, any data value, minus the mean. In this case, 108.4, divided by the standard deviation of 30.3. So I computed some Z-scores for you. Do you guys see that there? What do you guys see? What's the first Z-score? 0.32. Oh, that's kind of like Mr. Judge's height. Oh, but his was negative. Shoot, sorry. But this is positive. So what does that mean? Well, it means he's above the mean, right? Or the person's above the mean. And the score is what? Within what range? Isn't that the C range between -1 and 1? Okay? So what I did here is I showed you some examples of what, and then even, what grade do they get based on the curve grade? This time we looked at the Z-scores. So you have also a -1.53. What score would that be for the second test score? A D. You see how I have it labeled? And then a 0.88. What score is that? C. And so on. So I've labeled some of these curve scores to go over what we talked about last time and see how this looks on the standard scale, with the Z values being between -1 and 1 for a C score, right? Between 1 and 2 for B, over 2 for an A, and so on. You guys see what we have there? Why do you think I left the rest blank? Huh? So who could do them? Yes. I didn't want to take all the fun away. So you guys can actually work on these, okay? Because what might you see one day? You guys can see this on a test, right? What happens if you don't practice? I don't know. Anybody here good at it?